Alright, so today it looks like we want to find the zeros of a polynomial. Alright, so it says first list the possible rational zeros, right? And then use the graph at the right and your list above, synthetically divide to algebraically verify all zeros. Alright, so when I say use algebra, make sure you guys are using algebra. Alright, so, shh. Alright. So remember, when you guys are listing all possible rational zeros, you care about the number without the x, and you care about the number with the highest power of x. All right, so here you got 24, and then the invisible number here is a 1. All right, so you list all your factors of 24 over your factors of 1. So it's kind of nice that it's a 1, because that means in the denominator, I only have to care about plus or minus 1. All right. Which means for the numerator, you got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and then plus or minus 24. But because I only have this denominator of 1, that means my possible rational zeros happen to just be all of these numbers. All right, so none of them are actually pure fractions. They all happen to be integers, which is kind of cool. But those are all my possible rational zeros. I'm actually just going to go ahead and erase this, and that's my final list. So all the factors of 24 just happen to be my possible rational zeros. So now I have a graph here. It looks like that is a positive 3, and that is a positive 4. Both are on my list, all right? So what we can do is we're going to synthetically divide to verify that those are actually zeros. All right, so here I got 1, -7, 14, -14, and 24. All right, so remember to double check, there's no zeros here, right? So these numbers all come from there. I'm going to go ahead and divide by positive 3 first. The order you do it in really doesn't matter at all. I'm going to bring that down. 3 times 1 is 3. 3 minus 7 is a -4. -4 times 3 is a -12. That's a 2. That's 6. That's -8. That's -24. And that's a 0, which is what I wanted. So that means I can go at the bottom here. That 3, 0 is indeed a real 0. I know you can tell, but you have to show it algebraically. All right, so now you guys are going to, that is a degree 3. Right, that's a degree 3. I don't know how to solve degree 3s. So what I'm going to do is I'm just going to go ahead and set up another L right there. These are my new numbers. And now I'm going to use that x equals positive 4. I'm going to use that x equals positive 4. Once again, I'm going to bring down that 1. And I'm going to synthetically divide again. I'm looking for 0 at the end so I can verify that 4, 0 is a real 0. So that's a 4, that's a 0, that's 0, that's 2, that is a positive 8, that's 0, that's 0, that's 0. So that works. All right, so now that's a degree 2. That also means I can put here that that's 4, 0. I verified that. So now you have a degree 2 function. All right, really this wouldn't be here. But we started with a degree 4. That means the first time I divide, that's a degree 3. Second time I divide, that's a degree 2. So that means I'm going to create a polynomial, 1x squared plus 0x plus 2 equals 0. And now I'm going to solve that. Because again, this is a degree 4. That means I should have 4 zeros total, but I only see 2 real ones, which means I probably have 2 imaginary ones. All right, so I'm just going to simplify that to x squared plus 2 equals 0. All right, I'm going to solve this for x. So I'm going to subtract 2 from both sides. So you got x squared equals -2. I'm going to square root both sides. So x equals plus or minus the square root of -2, which I'm going to simplify as plus or minus I times root 2. All right, so your imaginary zeros, we can write that as plus or minus I root 2. All right, I'm not going to have you guys write it as a coordinate because you don't really know how to graph that as a coordinate. So if you just want to leave it as plus or minus I root 2, that's perfect. And again, I should have 4 zeros total because it's a degree 4 polynomial. But I hope that helps you guys.